So hi everyone, today we'll try to understand what is gradient tape. That is not that commonly used in Tensor, but of great help, and why we can, where we can use it, and why we should be using it for complex problems. Why it is required for complex problems. So let's understand what is gradient tape. So gradient tape is a low-level TensorFlow API, which allows you to manually compute gradients for your neural network over custom loss functions or custom training loops. So basically, like for example, if you have been into deep learning a bit, you might have used TensorFlow or PyTorch for training your models. Now the case with the default implementations is that you take a uh, training and test samples, you have a feature set, you have a ground truth, and then you call a model dot fit with predicted values given expected values, and then you calculate the loss function. That is the usual way of going with the projects. But eventually there would be some complex problems where this is not possible. You might not be having a default loss function, like for example RMSE, or you are making a custom loss function for your problem. Or it can be the case that the training loop that you wish to have is also customized. So I will show you an example later. So there are a few cases where gradient tape is of much more use as compared to model.fit, because model.fit is a high level TensorFlow API, whereas gradient tape is the lowest level of element for training gradients. So eventually, the more lower level API it is, the more flexible it is, but more complicated to use. So let's see where are the cases where we can use gradient tape instead of model.fit. So custom training loops, as I told you earlier, there might be cases where you don't wish to directly train. You have a training data set and a test data set. There might be cases you're constructing that data set, making minor tweaks, and in that cases you might need gradient tape. Apart from that, custom loss functions, as I told you earlier, I will be showing you an example. Apart from that, fine tuning pre-trained models can also be done using gradient tape, and model.fit might not be the best option to choose while training such cases. So let's see one of the examples that I've already used gradient tape for a reinforcement learning algorithm. We will be continuing how where such a case where we might not be able to use model.fit directly, but we need to use gradient.tape. So I'm taking this example from one of my previous blogs on reinforcement learning, where the loss function was defined by this particular equation, that is -1 into summation of log probabilities into discounted reward. So it is a reinforcement learning problem. Probabilities is basically for the actions to be taken. So take it as a multi-class probabilities, 1, 2, 3, 4, into discounted reward. So it is a concept coming from reinforcement learning. I think this is something that we won't be jumping in much detail, but I would be jumping more into the codes of how we are using gradient tape here. So as you can see that there was a loss function that we're using where there was no use of some ground truth. It was -1 probabilities into discounted rewards. Now now rewards is something that are calculated at every particular action taken. So when you take an action, you get a reward. There is no ground truth for these things. So in such cases, you do gradient tape. So here you can see the loop how we're using gradient tape. So gradient tape is nothing but calculates gradients for you, and then eventually you can apply these gradients over a neural network for training purposes. So with tf.gradient tape as tape, now we are calculating the probabilities, and here we are calculating the loss function. Here you can see that now using that loss function, I'm calculating the gradients for that loss function, and then using the optimizer that I have declared. Optimizer nothing but Adam. Straightforward implement tf.keras.optimizer.adam. Optimizer.apply gradients. Here you can see that it is a network that I'm trying to train using tf gradient. So here you saw that we don't have a ground truth, so we are calculating the loss function in a customized way, and eventually in such case we need to use gradient tape, and we can't use model.fit directly.